Okay, we're starting Chapter 2, Section 1, Systems of Linear Equations. For the first example, let us solve this system by graphing. So the first equation, let us make a table with x and y values, and let us choose x is 0. So when x is 0, let's substitute 0 into the x. So we have 0 plus 2y is equal to 0. Therefore, 2y is equal to 0, which makes y also 0. Now let's choose another point. Let's choose when y is 1. So we substitute 1 into the y variable. So we have x plus 2 times 1 is equal to 0. So x plus 2 is equal to 0. And solving for x is equal to -2. So let's plot our points, 0, 0, -2, 1. And let us draw the line. Now let's graph the second equation. So the second equation, let us do the same thing. Let's pick points for x and y. So when x is equal to 0, we substitute 0 into the equation. So we have 2 times 0 minus 3y equals -14. So we have -3y equals to -14. Divide by -3. Y is equal to 4 2/3. So we have 4 2/3. And then when y is 0, let's see what x is equal to. So we have 2x minus 3 times 0 is equal to -14. 2x is equal to -14. Therefore, x is equal to -7. So we have these 2 points, 0, 4 2/3. So 4 2/3 is about there. And -7, 0 is here. And let's see where they intersect. -7 2/3. And they intersect about here. And that point of intersection is -4, 2. So -4, 2 is where they intersect right there. So if there's a point of intersection, which means the system is consistent. And the solution is -4, 2. Moving on to number 2. We're doing the same thing. We're graphing the 2 equations. But let's graph these equations using y equals mx plus b. So this is the second method. So we want to rewrite that first equation into that form, which means we need to subtract 3x from both sides. So we have -y is equal to -3x plus 1. Dividing both sides by -1, we have y is equal to 3x minus 1. So now let's graph this line. We start at our b. So our b is -1, and then we go up 3 and over 1. So from the -1, you're going to go rise 1, 2, 3, and run 1. And let's connect the dots. And this is the first line. Now the second line, we want to do the same thing, rewrite our equation. So the equation is y equals mx plus b. So let's subtract the 4x from both sides. So we have -3y is equal to -4x plus 3. Divide both sides by -3. Therefore, we have y is equal to a negative divided by negative is positive. Positive 4/3 x. 3 divided by negative 3 is negative 1. So again, we start at our b. We start at negative 1. And then we rise 4. 1, 2, 3, 4, and run 3. 1, 2, 3. So this is our second line. And it seems like the solution is the y-intercept. So the y-intercept is 0, negative 1, and that is where they intersect. So 0, negative 1 is the solution. Therefore, the system is consistent. Let's move on to number 3. So number 3, let's solve the system of equation by the substitution method. So the substitution method tells us that we want to substitute one equation into the other. So let's rewrite the second equation and substitute the second equation into the first. So here let's solve for x. So x is equal to 3y plus 4. And all we did here was add 3y to both sides and solved for x. So now we want to substitute this second equation into the x of the first equation. So we have 6 times x, which is 3y plus 4, plus 5y is equal to 1. Now we distribute 18y plus 24 plus 5y equals 1. And let's combine like terms, which means we're combining our numbers and combining our variables. So we have 18 plus 5, which is 23y, is equal to 1 minus 24 is negative 23. Divide by 23, y is equal to negative 1. And then we substitute that y back into the equation to solve for x. So x is equal to 3 times negative 1 plus 4. So x is equal to negative 3 plus 4, which means x is equal to 1. Therefore, our solution is 1, negative 1, and that is where they intersect. Therefore, our system is consistent. Now moving on to number 4. Again, let's solve the system by the substitution method. So that means we need to rewrite one of the equation. So let's rewrite the first one and let's solve for y. So we have negative y is equal to negative 4x plus 3. Again, we can't have a negative, so let's divide both sides by negative 1, which makes this positive y is equal to 4x minus 3. So let's substitute this y into the second equation. So we have 3x minus y, which is 4x minus 3 is equal to 1. Again, make sure you put the parentheses so you distribute the negative there. So let's do that. Let's distribute the negative. We have negative 4x. And then a negative times a negative becomes a positive. So we have positive 3 is equal to 1. Combining like terms, we subtract 3 from both sides and combine the variables. 3x minus 4x is negative 1x. So we have negative 1x is equal to 1 minus 3, negative 2. Divide both sides by negative 1, and we have x is equal to 2. Now substitute the x into the equation, and let's solve for y. So y equals to 4 times 2 minus 3. So we have 8 minus 3 is equal to 5. So our solution is 2, 5, which means that is where they intersect. Therefore, the system is consistent because there is a point of intersection. And moving on to number 5, let's solve the system by the addition method, which is also called the elimination method, which means you want to eliminate one of the variables. So if we multiply the first equation by -1, that will eliminate our x variable. So let's distribute -1 to all three terms. -1 times 3x is -3x. -1 times -4 is positive 4y, is equal to -1 times 11 is -11. Now let's combine that with the second equation, and let's cancel the x. So now combining like terms, 4y plus 5y is 9y, is equal to -11 minus 7 is -18. Divide both sides by 9. We have y is equal to -2. Substituting the -2 for the y in either the first or the second equation, and we solve for x. So I'm going to substitute the -2 for y into the first equation. So 3x minus 4 times -2 equals 11. So 3x -4 times -2 is positive 8, is equal to 11. Solving for x, we want to subtract 8 from both sides. So we have 3x is equal to 11 minus 8 is 3. Divide both sides by 3. We have x is equal to 1. Therefore, our solution is 1, -2, which means that is the point of intersection. Therefore, the system is consistent. Now we will stop here in number 5, and we will continue with number 6.